Hello everyone, this is Francis Palma. I am going to present our work on defining design patterns for IoT APIs. While we are proposing those design patterns, our goal is to come up with some common design patterns. And to do that, we relied on existing or real API, RESTful APIs in the domain of IoT. Companies are developing their APIs without any standard design guidelines, and if there is a standard design guideline, the communication between the APIs and the devices, or the APIs and their clients, will be more reliable, and it will increase the understandability and reusability of the APIs themselves. We followed a systematic methodology, where we started with extracting the URI documentation from the APIs, and once we have the list of URIs, or the list of request URIs, we perform a split of the data, and at this stage we we split the data to 30-70 ratio. We use the 70% of the data as our analysis data, based on which we define the design patterns, and we keep the remaining 30% data for the validation purpose. So once we define the design pattern, we want to see to what extent our designing patterns are applicable or relevant to the remaining 30% data. We call them validation data, the remaining 30% data. Once we split the data, we perform the analysis of the UIs and document our observation from the analysis that we perform. And finally, we summarize and use a template to define our design patterns. To analyze the APIs, we used this set of 13 IoT APIs that exist today. There are other APIs. However, we chose randomly this sets of 13 APIs. Some of them are big player in the market, like Cisco or IBM or Microsoft, but there are also other APIs, small APIs, API providers in our set. IETF RFC standard defines the URI structure with a 5-component URI, which includes the scheme, the authority, the path, and the query, optionally the fragment. However, for our analysis, we extend the standard URI format to match our IoT APIs set, and we keep the scheme and the authority part. However, the path segment was splitted into 2 other nodes, like base and main, and we have the query as the same. However, we also discard the fragment part, because none of the APIs we analyzed had this fragment part. As I mentioned earlier, we use this template for defining the design patterns. That is also inspired from Gang of 4 design pattern template. For our work, we had to define some nodes or some elements of the URI that are that have been frequently occurred in the URIs, and one of them is the access node. And based on the method that we used, we found basically multiple other nodes in our analysis set, and these nodes behaved in a special way So we tried to abstract them and giving each of them a name and a definition so that we can use them later in our patterns. One of those nodes is access node, which we found in the base section of the URI, and it was specifically used to direct the URI to a certain section or part of the API. So another node is the parent node, which we found in the main section of the URI, and this node is not as special as the other ones since it only represents the full hierarchy that a resource might be in. And then there is a indicative nodes, which we found in the main section also, which behaves as an order or a query to get information or apply actions on resources. We have divided these nodes into three categories: so action nodes, filtering nodes, or informational nodes. So action nodes are the ones used to trigger a function or apply any of the CRUD functionalities on resources, and they usually take a form of an order to perform an action, whereas filtering nodes are used to target a specific group or state of the requested resources. And finally, the informational nodes are used to get information about resources metadata. This metadata cannot be modified nor accessed directly through the resources. Now we will present 8 defined design patterns, and one of the first design pattern is early directed URI. As you can see, we used also a graphical notation to represent the design patterns, and this early directed URI pattern suggests using a variable at the beginning of the authority section to direct the requested URI at a specific subsection of the API. For example, organizational ID or an area code or custom server name and so on. Then there is expressive request design pattern. So the expressive request pattern suggests using an action node in the main section when the intent of the URI is to perform one of the CRUD functionalities or trigger a specific function on a resource, while clearly stating the purpose of the URI and not just relying on the HTTP method, HTTP request method that is being used. In our article, we have some examples of these design patterns that we proposed. I'm requesting you to have a look at the article for more examples or use cases for this design pattern. Then there is another design pattern called me accessible resources. The me accessible resources pattern could be useful when we want to point at the currently authenticated user when requesting resources or performing actions that this user has access to. We can use a me node at the beginning of the main section. So this design pattern applies to the main section of the URI. And finally, we have this versionized resources pattern, and this suggests using a dedicated number in the same resource node as a separate node when the intent is to add the version of a resource in the URI to differentiate between the various types of updated functionalities that the API provides on the requested resources. So with this 8 design pattern, what we did, we used them to individually map to our validation set. So we had the 30% of the URIs that we set apart for the validation, and we found that 80% of the URIs from our validation set could be mapped, or we were able to map to at least one defined design patterns. And we also found that overall Early Directed URI and Versionized API are the most common design patterns within the IoT APIs. To further generalize the findings, we also mapped the URIs from the analysis set to the newly defined design patterns, and we observed similar distribution of the URIs over the design patterns. So at this stage, we can suggest that design patterns in IoT APIs are prevalent both from our validation set and also the analysis set. This figure shows a comparative view of the patterns that we found between the analysis data and validation data. In conclusion, since the design patterns are reusable solutions to recurring design problems, they are useful for increased understandability and reusability. And there is no defined design patterns that the IoT API developers can use. And we tried to analyze existing real APIs that are developed for IoT applications in the IoT domain. We defined 8 design patterns that could be applied and useful for IoT developers, and also it's help the client developers for the IoT APIs. For the future plan, we plan to develop a tool that can automatically detect design patterns in URIs, and not only that, that can also suggest design patterns for the developers when they're developing the APIs. And we also want to analyze more APIs, and if we analyze more APIs, we might end up with more generic design patterns that will extend the catalog of our existing 8 design patterns. I will be happy to answer your questions, and thank you for listening.